All right, hey everyone. I'm going to be trying something new today. So I'll be using the document camera for some of the questions because they're hard to write on the screen. So just be mindful of that. I'll signpost you. I'll tell you when that happens. But yeah, today we're actually going to start a new unit. Today we'll start trig. And I know trig was covered in Algebra 2 trig, right? But it's very important for you to be really good at these trig concepts for calculus. So that's why we're covering it again here in pre-calculus. Okay. So our aim for today is how do we find terminal points in the unit circle? Homework number 13 is going to be on a handout. Only these problems, 4 to 6, 9 to 11, 16, 17, 21 to 30. Okay, these are going to be quick. So 21 and 30, I know it's a lot of questions here, but they should be quick questions. Okay. All right. I'm going to actually jump into the do now. So let me jump to the slide for that. So here we're going to sketch a graph of x squared plus y squared is 1. And this equation represents the unit circle. Okay. And part B is the point root 6 over 6 and comma root 7 over 6 on the graph. Okay, we're first going to sketch this, and then we're going to determine if this point is on the graph. All right, here we are. Here's the solution. All right, here is the solution to part A. So in order to graph this, we're first going to isolate y. So we're going to separate into two separate equations. So we have y squared equals 1 minus x squared. And then from here, we're going to take the square root of both sides. So we have y equals plus or minus the square root of 1 minus x squared. Okay, so here I have the Desmos graph of it. In red, you're going to see that's the positive one, so positive root 1 minus x squared. And in blue, it's the negative one, so that's negative square root of 1 minus x squared. Okay, but as you can see, the x and y intercepts are negative 1 and 1, right? Negative 1 and 1. Okay, so that's your graph of the unit circle. And then for part B, the solution here is, well, to determine whether any point is on any graph, we just have to plug in the point into the equation. Okay, so we're going to plug this into x squared and then root 7 over 6 into y squared. And then we're going to see if that equals 1. If it is equal to 1, then it is on the graph. If it's not, then it's not on the graph. Okay, but as we can see, it'll come out to 6 over 36, right? That's root 6 over 6 squared. And then root 7 over 6 squared, that's 7 over 36. Okay, and that adds up to 13 over 36, which is not equal to 1. Okay, so 36 over 36 will be 1, but this is not equal to 1. Okay, so therefore we can conclude that this is not on the graph. All right, from there, we're going to jump into the definition of the unit circle. Let me give you the overview first. So the unit circle definition, the example that follows that. Then we're going to talk about the definition of a terminal point, 2 more examples, and then classwork. Okay. All right, but yeah, let me get to the slide for that. Okay, so here it is. So the definition of the unit circle. The unit circle is the circle of radius 1 centered at the origin in the xy plane. Its equation, as we just saw in the do now, is x squared plus y squared is 1. And again, here's the graph. Okay, so radius 1, center at the origin, it's a circle, right? Those are the 3 main things, right? It's a circle, radius 1, center at the origin. Okay. Please pause the video here if you need to copy this, but otherwise I'll move on to the next example. All right, here is the question. Okay, well, what I had in red here was what I would do in class, but yeah, I would just write out 1, 0 here, that's here, 0, 1, negative 1, 0, 0, negative 1, and radius 1. Circumference is 2 pi r, right, for any circle. 2 pi times radius is 1, so it's just 2 pi. But yeah, back to the example. So the point root 35 over 6 comma y is on the unit circle in quadrant 4. Find its y coordinate. Okay, so for this question, actually, I'm going to use the dot cam just to remind you of what this quadrant 4 means. So let me stop the share here. All right, so hopefully you should be able to see my screen now. And here I have this question. So here it is, right over here. Okay, so it says quadrant 4, right? So quadrant, let me write out the quadrants for you. And I apologize if this is kind of dark, like the lighting. So I'm actually on the max light volume for the dot cam, but hopefully you can make out what I'm writing here, okay? So quadrant 1 is here, and hopefully you remember this from Algebra 2, but just as a reminder, quadrant 2 is here, quadrant 3, and then quadrant 4. Okay, so it goes counterclockwise. Okay, start at quadrant 1, quadrant 2, 3, 4. Okay, that's what we're referring to when we say quadrant 4. Okay, all right, back to the lesson itself. All right, so here you have the solution. So you're gonna plug in, you're gonna plug in root 35 over 6 into x squared. So we know it's on the unit circle, right? So we can make use of this equation. So root 35 over 6 squared plus y squared is 1. And then from there, we can solve for y. Okay, so this squared is 35 over 36 plus y squared is 1. You're going to subtract 35 over 36 from both sides. You get y squared is 1 minus 35 over 36. So that's 1 over 36. Taking the square root of both sides, you get plus or minus 1/6. Now, we have to choose whether, we have to choose which one is correct. And we're going to determine that it's negative actually, because it's in quadrant 4, right? Quadrant 4, so that will be in this quadrant, right? So if you look at my cursor here, quadrant 4 is here. So the y coordinate is negative. Okay, so therefore it has to be negative 1/6 and not positive 1/6. All right, if you need to copy this solution, please pause the video here. Otherwise, I'll move on to the definition of terminal point. All right, here's the definition. So let t be a real number, starting at 1, 0 on the unit circle. So 1, 0, that's on the x-axis, right? And moving counterclockwise. So note that it's counterclockwise if t is positive, or clockwise if t is negative. Okay, so counterclockwise if it's positive, clockwise if negative. The ending point, xy, is called the terminal point, determined by t. And a really important note here, so the coordinates of that point can be determined by evaluating the cosine of t and the sine of t. Okay, so the cosine of this t value here is going to be the x coordinate, and the sine value of t, so sine of t, is going to be the y coordinate. Okay, and this is actually a running theme in math and physics. So if you talked about kinematics in physics class, you'll know that the horizontal component to any vector is cosine and is related to cosine, and the vertical component to any vector is related to sine. Okay, so cosine is horizontal and sine is vertical. Okay, so cosine is horizontally related, sine is vertically related. Okay, but yeah, with that in mind, if you need to copy this, please pause the video here. Otherwise, I'll move on to the other 2 examples, I believe is next. All right, all right, here we are. So here's this first example. Find the terminal point on the unit circle determined by each real number t. So we have 3 pi, negative pi over 2. Okay, and yeah, let me get to the document camera for this. All right, so hopefully you can see my document camera again. Let me change the page. All right, here's the question. All right, right here. Okay, so for part A, let me zoom this up actually. Okay, so part A, t equals 3 pi, right? So 3 pi is going to be, well, pi radians is 180 degrees, okay? And 3 pi is going to be 3 times 180. So 180 plus 180 plus 180, so 360 plus another 180, that's 540. So 360 is a full rotation, And then another 180 would bring us to 540 or 3 pi. And our job is to just identify the coordinate here. And we can see that the coordinate, right, assuming that this is on the unit circle, right, that's going to be -1, 0. Okay, and that's your first answer right here, -1, 0. Okay, part B is negative pi. So negative pi on the unit circle, that's going to be, so negative pi, remember negative, as we just saw, right, that's a clockwise rotation, so that would be this way. So negative pi, -180 degrees, that's right here, right? So then the point is this is actually at the same location as part A. So that'll be -1, 0. So -1, 0 for part B as well. And then part C is -pi/2. I'll draw that up here. So -pi/2. So pi, remember, is 180. 180 divided by 2, that's 90. So this is going to be -90 degrees. So -90, that's over here. So what's the coordinate over there on the unit circle? That'll be, right, the x-coordinate is going to be 0, y-coordinate is -1. So it'll be 0, -1. Okay, so 0, -1 is our answer for that. Okay, all right, for the next question, actually, let me just stay here on the dot cam because I did want to draw something for this. Okay, sorry, I know this is hard to see, but let me read it for you. So it says, what is the terminal point P, x, y determined by t equals pi/4? So we have to determine the point determined by pi/4. And we're going to use the fact that P lies on the line y equals x. So if you're thinking about it, actually, we could actually solve this using the cosine t, sine t note that we saw earlier, right? So we could just evaluate cosine pi/4, sine pi/4 using our calculator, or if you remember it, right? But we're going to solve this algebraically. Okay, so P xy is the intersection point of the unit circle and the line y equals x. Okay, so let me draw that here. So here you have a unit circle, and here you have a line y equals x. Okay, so the intersection, so t equals pi/4 is going to be in the first quadrant, right? Pi/4 is 45 degrees, by the way. So 180 divided by 4, that's 45. And that'll place us right here. Okay, so we're trying to find the point right there, wherever the coordinates are. And we're going to make use of this equation here. So we're going to substitute x for y in the equation, the unit circle equation, right? And we can make use of this, right? So x equals y. So we're going to substitute x for y. So we'll replace y with x. So this will become x squared plus x squared is 1. This simplifies to 2x squared equals 1. And then divide both sides by 2, you get x squared is 1/2. Okay. Taking the square root of both sides, you get x equals plus or minus root 1/2. And yeah, let me show you the step here. So you can break this up into root 1 over root 2. And we know that root 1 is just 1. And then we have root 2 in the denominator. Yeah, and then you're going to rationalize by multiplying by root 2 over root 2. Okay, and that's how you get this final answer. Okay, so 1 times root 2 is root 2, then root 2 times root 2 is 2. Okay, now we have to determine whether it's positive or negative, but we know that this point, as you can see from the diagram, is in quadrant 1, right? So quadrant 1. So it's going to be positive root 2 over 2, and since x equals y has that same value. Okay, so we know x is y, right? So same value. So therefore, our final answer is going to be root 2 over 2, root 2 over 2. Okay, that's our final answer. Okay, so let me move on to the classwork. So if you need, actually, so I know this is hard to see. So actually, let me share my screen again for the lesson. Okay, so if you need any of these solutions, please pause video here. So these are the answers to this first example. This is the answer to this second example. Okay. But yeah, from there, I'm going to go on to the classwork. And for that, I need the dot cam. So let me stop the share. Okay, so let me get to the worksheet. worksheet was right over here. Okay. All right, here's the worksheet. All right, so first question is for numbers 1 to 3, use the following triangles to calculate the trig ratios for sine and cosine, and then find the terminal point P. Okay, so here we have the 45, 45, 90 triangle. Here's the 30, 60, 90 triangle. Okay, and also another reminder, 45 degrees is pi over 4 radians, 30 degrees is pi over 6 radians, and 60 degrees is pi over 3 radians. Okay, all right, so if you remember the acronym, right, SOHCAHTOA, all right, let me write that over here. SOHCAHTOA, all right, so this is supposed to help you remember the definitions of sine, cosine, and tangent. Okay, in this lesson, we only cover sine and cosine. So sine is the ratio between the opposite side and the hypotenuse for a right triangle, right? Cosine is the ratio between the adjacent side and the hypotenuse. Okay, so sine of pi over 4. For that, remember pi over 4 is 45 degrees. So we're going to go to this triangle here, 45. And then you can evaluate opposite over hypotenuse. So this would be 1 over root 2. And then we have to rationalize that. So that will be, let me zoom in here. Okay, so that will be root 2 over root 2, and that's root 2 over 2. Okay, that's your first answer. Cosine pi over 4, that's adjacent over hypotenuse, right? So we're going to go to adjacent over hypotenuse. So it's actually the same thing, right? 1 over root 2, right? Adjacent over hypotenuse. But as we know, that's equal to root 2 over 2 from part A. Okay. And then follow-up question to that was, what's the terminal point determined by this? That's going to be root 2 over 2, comma root 2 over 2. Okay, that's your answer for part C. Okay. Okay. So I think because this is hard to see, I'm going to come back to this when I have to use it. But let me actually go back to the lesson. Okay, I'll share the solution there. Okay. So yeah, here was the question we just did. And then we're going to go to sine of pi over 6 and cosine pi over 6. Okay, so sine of pi over 6, remember pi over 6 is 30 degrees. So as you can see here, right, it's going to be opposite over hypotenuse. That'll be 1/2. Cosine pi over 6, that's cosine of 30, right? So that's adjacent over hypotenuse. That's root 3 over 2. That's right here. And then for the terminal point, right, as we know, it's cosine of that value, comma sine of that value. So that'll be whatever we just solved for. That'll be root 3 over 2, comma 1/2. Okay, so this is the cosine value. This is the sine value. All right, if you need a copy of this solution, please pause the video here. All right, and then we'll move on to question 3. All right, question 3 was sine of pi over 3 and cosine pi over 3, and then the terminal point. Okay, so sine of pi over 3, so pi, remember, is 180. So 180 divided by 3, that's 60. So we need to find sine 60 and cosine 60. All right, sine 60, that's over here. So opposite over hypotenuse, that's root 3 over 2. And then cosine 60, that's adjacent over hypotenuse. That'll be 1/2. Okay. All right, so root 3 over 2 for sine, 1/2 for cosine. And this is your terminal point. All right, here's the cosine value, here's the sine value. All right, for the other questions 4, 5, and 6, I'm gonna go back to the DocCam because yeah, I want to draw the diagrams. Okay, so yeah, if you need 3, please pause the video. But yeah, I'm gonna go back to the DocCam. Okay, so here is question number 4. All right, so it says if t is in quadrant 1, then the coordinates are both positive, right? And then we have to determine about for the other quadrants. So we'll see that. So quadrant 1 is here, right? So both the x and y coordinates are positive. For quadrant 2, Here you can see that the x-coordinate is going to be negative, but the y-coordinate is going to be positive, right? Oh, sorry. I just realized we can't see my writing. Okay, sorry, let me backtrack. So quadrant 1, both x and y coordinates are positive. Quadrant 2, the x coordinate is negative, y coordinate is positive. Okay, so this is going to be negative, positive. Okay, all right, negative, positive. For quadrant 3, so we see that there's going to be negative x coordinate and negative y coordinate. Okay, so there's going to be negative, negative. Okay, quadrant 4, that's over here. That's going to be positive x coordinate because it's on this side, and then negative y coordinate. So positive, comma, negative. Positive, comma, negative. Okay. All right, those are your answers to part 4. Okay. All right. Next we have questions 5 and 6. All right. So here, what's the terminal point P when t equals pi over 2? That's our first one. Okay. So t of pi over 2. Let me draw this in here. Okay. Actually, let me draw on this side. I know we need some space. All right, so pi over 2 is 90 degrees. So 90 degrees, that'll be up here. So just at this point, just ask yourself, if this is on a unit circle, what's the coordinate? All right, the coordinate here at this point is going to be 0, 1. 0, 1. Right, x coordinate 0, y coordinate 1. All right, next we have part B. That's t equals pi. So pi is 180 degrees. That'll be over here. Okay, the coordinate here is going to be negative 1, 0. Okay, negative x coordinate. So negative 1, 0. Y coordinate 0. Okay. So this is t equals pi. All right. Next we have c. That's 5 pi over 2. All right. So 5 pi over 2. So pi over 2 is 90, right? So just do 90 degrees 5 times. So 90. That's 1, 2, 3, 4, 5. We're actually going to end up at the same location as pi over 2. So that's the same thing as part A, actually. So it'll be 0, 1. Okay, that's your answer for part C. Then part D, we have negative 3 pi over 2. Okay, so negative is clockwise, right? So negative 90 3 times, that'd be this 1, 2, 3. That'd be right over here. So what's the coordinate here? That's going to be 0, 1. Same thing as parts A and C. So 0, 1. Okay. All right, it's followed by t equals 0. So t equals 0, we don't have to go anywhere. So that'll be right here, right? We start here on the unit circle. So the coordinate there is 1, 0. And then lastly, we have 2 pi. All right, 2 pi is 360. So that'll be actually the starting point. So that'll be 1, 0. Same as part E. Okay. All right, at this point, let me go back to the lesson so that you can see it more easily. But yeah, I wanted to use the DotCam because I want to draw the angles here. But yeah, here are the solutions to 4 and 5 in case you need it. Okay, so here's 4, and here is 5. Okay, 0, 1, negative 1, 0, 0, 1, 0, 1, 1, 0, 1, 0. Okay, all right, pause the video here if you need that. But yeah, we're gonna close with question number 6, and for that, I will go back to the DotCam. All right, question 6. So these are more angles, just a little more complicated because they're not on the axes. So pi over 4, 5 pi over 4, I mean. So pi over 4, all right, pi is 180, right? 180 divided by 4, that's 45 degrees. Right, 45 times 5, So 45, as we know, that's like half a quadrant. So that we have to do that 5 times. So 1, 2, 3, 4, 5. That's going to be in quadrant 3, located here. Okay. And what's the coordinate there? So it's going to have a negative x coordinate and a negative y coordinate. And at this point, you can ask, well, one, you can use your calculator. So you do, well, make sure your calculator is in radians. You do cosine of 5 power 4 times sine power 4. But as we know from the previous question, right? So question number 1 here, we know that the sine of power 4 and cosine power 4 are both root 2 over 2. The only thing we have to adjust is the sign. Okay, so root 2 over 2. Keep that in mind. So negative x coordinate, negative y coordinate, it's just going to be negative root 2 over 2, comma, negative root 2 over 2. Okay, all right, that's your first answer. Part B, here we have, let me draw on this side. So negative pi over 6, so pi over 6, that's 180 divided by 6, that's 30 degrees. All right, that angle is 30 degrees, but it's in quadrant 4. All right, so at this point, you have to remember the sine and cosine values for 30. And actually, we solved it over here, but yeah, just adjust for the sign. So let me scroll up for those values. Oh, actually, I didn't write it here. But yeah, so if you remember from your notes, cosine of pi over 6 is going to be root 3 over 2, and sine of pi over 6 is going to be 1/2. Okay, but the only thing we have to adjust for is the sign. So here it's positive in this quadrant, positive x coordinate, I mean, and negative y coordinate. So this is going to be equal to right here. So root 3 over 2, that's positive, positive x coordinate, and negative 1/2. Okay, that's your answer to part B. So root 3 over 2, comma, negative 1/2. All right, next we have part C. Let me draw that here. We have the space. So that's negative 45 degrees. So at this point, all right, it's going to be positive x coordinate, negative y coordinate. But what's the cosine value of pi over 4? It's going to be root 2 over 2, right? So same thing as part A, right? But it's going to be positive root 2 over 2, comma, a negative y value. So it's negative root 2 over 2. Okay. All right, that's part C. And then part D, let me write that here. Part D, so that's 3 pi over 4. So 3 pi over 4, that's 45 3 times. That's 1, 2, 3. That's 135 degrees. So over here. So yeah, it's also going to be root 2 over 2, like the base value, quote unquote. But here we just have to adjust for the sign. So here it's going to be a negative x coordinate, so negative root 2 over 2, and positive root 2 over 2 for the y coordinate. Okay. And lastly, we will finish with negative 5 pi over 6. Okay, so pi over 6 is 30. So 30 times 5, it's 150. That'll be negative 150. So negative 150, that'll be over here. And here, so this angle here is 30 degrees. That's the important one. And so we just have to, so cosine of 30 degrees, cosine of pi over 6, in other words, is root 3 over 2. But it's going to be negative, right? Because we're on the negative side of the, oh, sorry. Hopefully you can see that. It's going to be negative root 3 over 2, since we're on the negative side of the x-axis. So negative root 3 over 2. And then the y-coordinate is going to be 1/2, but it's going to be negative also, right? Because here's going to be a negative y-coordinate at this point. All right, and that'll be your final answer. Okay, so just to recap, negative root 2 over 2, negative root 2 over 2 for A. Part B is root 3 over 2, negative 1/2. For B, for C, it's root 2 over 2, comma, negative root 2 over 2. Part D is negative root 2 over 2, comma, root 2 over 2. Part E is negative root 3 over 2, comma, negative 1/2. Okay, and let me show you the actual answers on the lesson because it's easier to see. And that's right over here. Okay, so these are your answers for number 6. All right, but that is all I wanted to say for today. So if you have any questions on this, make sure you ask me in our synchronous Zoom session. But yeah, other than that, have a great day, and I'll see you all soon. Take care.